Hello, welcome to our presentation about Tasrif, a Python tool for processing wearable and digital health datasets. Efforts on sensor miniaturization now allow devices to inexpensively monitor an extensive array of health variables such as physical activity, heart rate variability, oxygen saturation, and sleep. This is done following the mounting evidence of the role of sleep in well-being and its relationship with disease and mortality and its economic impact. The data generated is then stored and curated in a step that comprises privacy-aware storage. There is a non-trivial amount of data processing that needs to be done for every new data collection. These steps, commonly known as data wrangling, unfortunately can have a steep learning curve at an entry level for research clinicians and data scientists, who may not have deep knowledge of time series analysis. Specifically within the preprocessing domain, datasets can be stored differently. In addition, preparing the data to be an input for a machine learning model is a non-trivial process. A 2020 report by Anaconda shows that 45% of a data scientist's time is spent on preparing, loading, and cleaning the data for the task at hand. Finally, researchers may alter their preprocessing decisions by adding or removing features or including additional test sets to further evaluate the forecasting model. Therefore, we propose our tool, Tasrif, as a system to remove the entry barrier of wearable data wrangling faced by digital health researchers. Our main goal is to speed up the process of data preprocessing for machine learning practitioners working in the digital health domain. Tasrif offers the access to official lifestyle datasets such as My Heart Counts, Zenodo Fitbit data, Sahha datasets, and more. Tasrif users are able to load the mentioned dataset into memory with one line of code, given that the user has permission to access our data fabric server. Tasrif's main idea is to form a processing pipeline by chaining multiple functions in an order. Pipelines can be run sequentially or in parallel. Hence, Tasrif users can conveniently leverage multi-threading. Tasrif comes with a data reader class for importing your preferred dataset. It provides a variety of processing operators specifically developed to deal with wearable time series data. It is seamlessly compatible with complementary libraries such as Facebook, Scats, and tsfresh for time series extraction. Tasrif contains observers. Observers are useful for seeing how the operators change your data at each step. They are also useful to debug your pipeline and to see if your prepared data can act as an input for a machine learning model. We'll start with looking at My Heart Counts dataset. Loading My Heart Counts will show us metadata of each participant, while the participant's actual time series data file is referenced in the data.csv column. In order to read My Heart Counts dataset, we begin by creating a fresh environment in Python and installing Tasrif in Python console or a Jupyter notebook. We first import Tasrif data readers module and provide My Heart Counts the parameters it needs, such as the path of the dataset and the number of participants to load. The user can load however many participants and can filter the type of activity directly within the data reader. As mentioned earlier, some operators can be run in parallel, such as the compose operator. In the following code, I am displaying the number of logical cores in my machine, 8. A user may take advantage of this to read different portions of some dataset and achieve faster results. If we would like to load all of My Heart Counts dataset, which is larger than my machine's memory storage, Tasrif will return a Python generator of each participant individually. After loading My Heart Counts, a researcher may need to compute statistics of patients starting at a different hour than midnight. Hence, we provide operators such as set start hour of day to cope with such cases. The pipeline can use the shifted time and continue with its operators. Visualizing the days after calling set start hour of day now shows the preferred start of the day. Another challenge faced by researchers is to filter out non-consecutive days. Creating code for doing so can be non-trivial and error-prone. In the plot, I am displaying all days for a particular patient, and I would like to remove the non-consecutive day, which is the last row. Tasrif provides the filter operator, which can work on three levels: at a row level, at a day level, and a patient level. In the following code, I am filtering our dataset to include days which have more than 2500 steps and are at least consecutive by 2 days but not more than 5. After a user is satisfied with the operations done on the data, the user can append the operators to a list as an input to the sequence operator to form a pipeline. As mentioned before, you can debug your pipelines using observers. The plots earlier were generated by the Visualize Days observer, where the user can configure the plot size and more. The observer is transparently run after every operator in a pipeline. The researcher may use simpler observers such as printing the first few lines of a data frame, just to see if the data frame can be accepted by a machine learning model. Users can create their own operators easily by subclassing the map processing operator. In the following code, I am returning two columns that I'm interested in: value and the record ID. You can use your own custom operator to attach it to a pipeline. A common practice in supervised machine learning models is to reframe the time series data into a fixed set of time series values per sample. Sliding window operator achieves this, returning the input, the labels, and the output for a machine learning model. In the code, I take an extra step to use the output for a time series feature extractor, tsfresh. Tasrif is able to call third-party packages for time series feature extraction, such as tsfresh and cats. Finally, you can use the extracted processed data and use it as an input for a machine learning model. In conclusion, Tasrif is an ongoing effort and we plan to release further functionality in upcoming releases. We are considering to develop a platform for creating pipelines without the need of Python programming skills. The takeaway message is that Tasrif is built to speed up the conversion process from raw wearable data to data that act as an input for a machine learning model. The repository is publicly available on GitHub under QCRI's user. As a team, we are excited in testing Tasrif internally and externally with real data in order to enhance Tasrif's functionality. Thank you for listening.